Hello, everybody. I hope you had a good lunch. I had a very quick one, and it was delicious. All right. My name is Daniel Petranek, and I work at Fluree, where we are making an immutable graph database with Clojure. And it's really cool. And I'm going to start with what may appear to be a digression, a non sequitur, but I would like to assure you that it is in fact a sequitur, and you're going to love it. It's great. So, stepping back into a serious problem of shipping boxes in the days of yore. And I want to time travel back to 1950. And say you're a goods manufacturer, maybe you manufacture sewing machines in Chicago or something, and you'd like to sell your great products to somebody in London. In order to do that, you've got to take your stuff, you've got to put it in a special box that's going to protect it for this long journey ahead. And you load these boxes onto a truck. The truck takes it to a train depot that's unloaded at the train depot, arranged physically with other goods that are similarly destined, that is loaded onto a boxcar carefully so that nothing falls over. The train goes across the nation. It reaches a port city eventually. It's unloaded from the boxcar, loaded back onto a truck. The truck takes it to the docks. There again, you're unloaded. Now you've got to rearrange and put the boxes close to the ships that are going to the places where you're going. You load them onto a pallet. The pallet is covered with a net. It is lifted by a crane over the ship, dropped into the hold. There it is maybe unpacked, carefully arranged because you've got to take into account how heavy these boxes are, what's inside of them, are they going to break? And what's next to them? You don't want to store like anvils next to bags of coffee. That's going to cause problems for the coffee, not for the anvils. Maybe problems for the ship. So it's a very long journey. And then you go across the ocean. Eventually you'll reach your port of call. It may not be the first one, so maybe these goods need to be rearranged on the trip there. And you reach your port of call, you have to load it back onto a pallet, back up on a crane, over the edge, onto a dock, where it needs to be unpacked. They will literally break the box open to look inside, assess any tariffs. Carpenters will have to come fix it up. And then you do this whole process again to get it inland. So, needless to say, this is a long and expensive process. And this is the simple version. This is the easy one. If you're trying to ship through New York has cursed geography for logistics. The trains can't get to the actual docks. So what they do is they take the train cars, put them on a boat. The boat is floated across the river. Then they're unloaded there. It's ridiculous. And as a consequence, at each step of the way, you had to have literal human person who had to become physically acquainted with this box and move it from place to place. And it may not be a box. It may be just a bundle of pipes or sacks of concrete. It's heavy work. It's dangerous work. People died often. You were often injured. It was irregular work. You might have 4 ships come into port and you're busy for a week straight and then nothing for a while. So these guys had a hard job. And every step of the way, when somebody touches it, you've got to pay for freight, you've got to pay for labor, and if you're unlucky, you also have to pay a couple bribes. It's not a great scenario. Which brings me to my thesis about this problem. Shipping across oceans was expensive, risky, because storms happen, right? Cargo tips over. It could get destroyed. It's sitting around on a wharf. Guess what happens at wharfs? Rampant theft. It was a huge problem. Something like 20% of goods could disappear just sitting on the wharf waiting to get picked up. And so this just was not worth it for many categories of goods. It was just too expensive. But that's not the world we live in today. Shipping things isn't that expensive. We have containers. Steel or aluminum boxes of a very regular size that can fit on a boat, can fit on a train, can fit on a truck. There are standardized cranes that can lift them no matter where they came from and move them around. They can be stacked. They can be stored anywhere. You can have refrigerated ones. And I can knit hats in my living room and sell them to almost anyone in the world. I've got a laptop here that is the result of a global supply chain that I paid less for this than even a computer, a tiny fraction of its performance was capable of 20 years ago. So containers didn't happen until 1956. And it's an obvious idea. Like, people, you just had to stand on a dock and look at the chaos and say, oh gosh, there's got to be a better way. And there was. But there are political, social, economic reasons why it just didn't happen. And so in 1956 wasn't the first container, it was the first integrated logistical chain where you've got the boxes, you've got the containers, you've got the ships, you've got the cranes, you've got the trucks, and it all works together for the first time. The rest is history. Like, the world changed once this happened. The cost of shipping dropped orders of magnitude. And it's a fascinating history. But it reminds me of something, or at least that story of before the container reminds me of something that we do every day. Sharing data is rough. And I'm going to specifically say sharing data across trust boundaries is expensive, risky, and not worth it for many categories of applications. And let's be clear on what I'm saying, because it is just what it says, but let's define it. What do I mean by sharing data? I just mean bring it together. 2 different places, n different places, wherever. Sometimes you want to look at 2 different sets of data at the same time and make a decision based on that. Maybe you're going to dispatch some fancy side effects, flash some lights. Maybe you're going to generate new data, do some synthesis. This is what we do all day long. And what's a trust boundary? I'm just talking about any place where, like, there's a set of people who are allowed to read and write the data, right? This can be between 2 different companies. This can be between 2 different departments in a company. I've seen that. This can be in a Byzantine peer-to-peer network with 1 person versus the entire world. And I'm just claiming that's expensive. And I'm not just talking about having to fork over some $bucks for, like, literal bytes of data. I'm talking more about the indirect costs, the time and the labor and the emotional anguish of trying to make it happen. Because we've got to do a little dance when we want to make it happen. I've got to figure out the transport. What server is this on? How do I talk to it? Is there an HTTP API? Do I have to find a TCP socket? What are the rules here? And when I finally can connect to the database, it has to know who I am somehow. Do I have to figure out OAuth or OAuth 2.0 or Open Connect ID? Or do I have to email an admin somewhere to get me set up? And once that hoop has been jumped through, now I've got to obtain access. There's authorization rules. What am I allowed to see? What am I allowed to change? This is like, we've all lived through this. But even once you've got access to the data, you're allowed to see it. It's not easy. Sometimes it's like, what am I looking at? I'm going to steal a story from a guy we work with, is a President Elliott, who worked at Citibank in 2008, and in September of 2008. And specifically, on a Friday after the close of trading in 2008, Citibank got a call, and the call was, hey, Lehman Brothers Investment Bank is not going to exist when markets open on Monday. And we're going to try to auction off all their assets to recover some value from this debacle. And here's their data. Here, like, you've got full access. We're giving you their literal data files. Please, look at what we've got, look at what they've got, figure out what's worth bidding on, and inform your CEO, and he will get a bid in, and we'll have us a grand old auction real fast. And they couldn't do it. JP Morgan, Chase Bank, Goldman Sachs, they're all, like, the bids are rolling in. Saturday is gone, and the CEO is calling in hourly. Give me something that I can bid on. All the good stuff's getting taken up. Finally, Sunday afternoon, they finally are like, okay, we've finally figured out how to correlate the data in our database with their database. And we got some bids out. And then Sunday evening, they get another call. And Elliott talks about seeing analysts around him at their desks literally weeping because they just received news that AIG, the insurance company, was doing the exact same thing. It was going to be gone. And AIG was an order of magnitude larger, and they just couldn't handle it. They had full access. Consider if you want to write to the data. I want to add to this store of knowledge. Do I just send information to you, and maybe I get a validation error, maybe I get an error back and I know, okay, that wasn't the right shape. But what if you don't get an error? Does that mean that you did it correctly? Is somebody having a bad day because something screwed up? That data needs to be validated. And who knows, maybe it is. You don't know because it's on that side of the trust boundary. So, but sometimes we usually don't want to just write the data. We want to do synthesis. Like, this is the good stuff. This is where the value comes from. We want to combine it with other stuff and extend it. And I'm not going to write that on the other side of a trust boundary. I had to fight so hard to get access to this. I'm not giving away the stuff that I've got. I'm putting it over there, over these claws and spikes and thorn traps. No, I'm going to create my own. This is my data. You see the problem, right? Like, it propagates. And now everybody's miserable, and this project is not fun. Maybe documentation can save us, right? Just follow the docs. And sometimes that is a happy path. But there's a lot of things that documentation has to get right before you can actually use it. And anything is missing, you're unhappy. Yep. And so that leads me to this thesis: sharing data across trust boundaries is expensive, risky, and not worth it for many categories of applications. Even if you get all 5 of those steps worked out, this is risky. Who here has worked on a data integration that failed to produce any value because of reasons completely removed from technical implementation? Yeah. We once spent 4 months integrating our product with another product, and 9 months after we released it, that business disappeared. They went bankrupt. That was just a waste, all in vain. We made it work, and it was nice, but for reasons completely outside our control, it just didn't work. So this doesn't happen. You don't share data unless it's too expensive not to. So there's an entire class of applications that just are not even feasible, not from a technical standpoint, but from just the system is gunked up perspective. However, I don't think it has to be that way. Here's a proposal. Each of these little data islands, these trust boundaries, the reason they're so expensive to access is because each one is this special snowflake, a unique and beautiful creation, lovingly, hopefully, created by people who care about what they do. But they all choose to do it differently. So let's simplify the shape of the data and get rid of that application server, that special snowflake. And I think we can do this. And I'm going to talk about people who've been thinking about this for a long time. So this is another historical sequitur, so walk with me. In the 1990s, Tim Berners-Lee created the World Wide Web, and he saw that it was good. And then he took another look and thought, well, you know, maybe we could make some improvements. Because what the web was, these HTML documents with links between each other, these are readable by humans, but these aren't readable by machines. The semantic information in these documents are encoded for intelligent thinking creatures. Machines can't understand it. It's not regular. Famously, HTML is not regular. I don't know if you've seen the Stack Overflow question about how to parse HTML with a regular expression. Don't try it. It won't work. And so we developed heuristics for discovering semantics. Google was like, we can just figure it out by how things are linked together. We'll just follow the links. But if we had linkable data, a web of data instead of a web of documents, we could encode explicitly the semantics of that data in a way that is automation friendly. And so the semantic web people thought about this, and they argued with each other, and the entire world just moved on. They were like, ooh, Web 2.0. We've got Ajax, JavaScript. Cool stuff is happening. But the semantic web people kept working, and they kept arguing, and they kind of grinded up until they got a really useful, some really useful ideas and tools that I don't think people have really paid serious attention to for a number of reasons, but one of them I think is just the moment had passed. People were like, we can make documents work. It's fine. They're good enough. Worse is better. Whatever. And so at the foundation of all these things that they came up with is the resource description framework, RDF, which is just a notation for graphs. It's a simple, universal way to model data without sacrificing any expressivity. And RDF is just triples. Subject, predicate, object. Daniel, that's me. Favorite food, mango pie. I made my first one last week and it blew my mind. So that's new. Which, if you've been writing Clojure, may be familiar to you. In this form, entity, attribute, value. It's the same thing. I think it actually came from the same place. If you find Rich, like, just ask him. It's like, is that RDF? Because I think it is. It's a good idea. And it's the simplest schema. 3 columns. And anything can be boiled down into this without losing any expressivity. And the cool thing about it is you can have different notations for it because RDF is cool, but who knows about RDF? You know what people know about? JSON. This is the same data, same shape, but this looks a lot more familiar, right? JSON-LD, that's JSON linked data, is a W3C standard for encoding graph data into JSON. And basically, it boils down to adding global namespacing. That's what that at context is, giving global context to your data. And I'm not going to get into this because I don't have enough time and there's too many cool things to talk about. But this is a rabbit hole that's worth going down. If you have to talk to different systems, this is cool. And they built this whole stack of really useful tools. You've got RDF on the bottom. JSON-LD is just a different representation of that. You've got this shape constraint language for validation, RDFS, the RDF schema sort of data, the web ontology language. And these are all just, they got language in the name, but they're not different languages, they're just data. We in Clojure have pretty explicit experience with the power of data as a language, as a DSL. And they had the idea first, and we all forgot about it. And it's really cool. And then there's Sparkle, which sits on top. Sparkle is a graph query language, and it's magnificent. You should check it out. And the entire point of this is you interact with these technologies literally every day, and you probably don't know about it. Every time you do a web search and you see sort of an info box pop up with just the answer you're looking for, that's JSON-LD in that web page. If you've ever heard of Mastodon or ActivityPub, the protocol that it implements, and the entire Fediverse, it's powered by JSON-LD. And it's cool. It works. Federated social networks can be a thing. And the data representation helps. So, we talked about simplifying the shape of the data. So that's what that was. Semantic Web has got that covered for us. We didn't have to do anything because it's already been done. We can decompose any arbitrary data into a very simple schema. And now we've got to do something about the special snowflakes that stand in front of the data that we want to access. These application servers. And we've all seen this, right? We've all done this. I didn't put any numbers next to it because who knows what order this is going to happen in. But this is the basic stuff that needs to happen. So what if we didn't have a special, beautiful, unique API to do this every single time? What if this was standardized and made as small as possible? Let's move transport into the data layer. Let's make our database speak HTTP. Now it can sit there on the web, anybody can talk to it with JSON because that's what they're doing anyways. How many application servers are glorified HTTP to JDBC converters, you know? And let's move authentication into the database as well, right? The database, Postgres has this. Who here has used row-level authentication or authorization? It's cool. It's not very widespread. It's there. We're not the first people who have this idea. Well, that might be a good idea. Let's move authorization in there as well. So Postgres did it, so it's got to be a good idea. They don't make mistakes. And let's make sure that what data does come in doesn't break our semantic guarantees, our semantic model. And this goes beyond type level guarantees, like is this a UUID? Is this a varchar 50 or varchar? Who knows? We want semantic guarantees, like is this thing valid compared to that thing? Like, are you allowed to make this sort of change? It all kind of, there's a lot of expressivity that we put into the application server. And I'm saying, let's just move that into the database so it's regular. And all that's left here is orchestrating side effects, right? I don't want to put that into the database. No, thank you. But When the application server is only doing that, it's not a guardian of the trust boundary anymore. It's just another client. It issues a query, looks at the results, and either does or does not do the side effect, right? This is a Lambda function now. This isn't an application server, it's just a Lambda function. So, that feels pretty good. Fluree, right? We've got a database. And to tie this back to our metaphor, the container is JSON-LD, and all the infrastructure for handling it is Fluree. Other things, like we're not the only ones who think JSON-LD is a good idea, and a lot of people are starting to figure out the benefits of having very regular self-describing data. Fluree, we make our database a first-class citizen of whatever system it's in. It doesn't need to hide behind a guardian. It can negotiate transport, it can authenticate requests, it can authorize access, validate inputs, and like persist data, of course. And because we're Clojure developers, we chose to persist it as an immutable ledger. These are RDF triples that have been extended to add a temporal dimension and give it a certain retract semantics. We map things to integers to compact them and also to make comparison and sorting a lot faster. So it's a septuple, not a triple anymore. But it's the same basic idea, an extended triple store. And data transport, we just speak JSON. You give us JSON, okay, and this is a Clojure conference, so just so you know, we also do Eden. Like, you can use it properly. And it's great that way. So this transaction is just a hunk of JSON. If you want more advanced, we've got some syntax that you can do to do more targeted updates, but if you just want to schlup data in, you can do that. The query language, like, it all boils down to an internal representation. Right now, what this is that I'm showing you is just a sort of datafied version of Sparkle. But we've also got parsers for SQL and GraphQL and actual Sparkle. So if you want to stick to the strings, we should be able to handle that. And we did steal the really cool EQL style select statements. Those are a good idea. Our authentication is simple. It's just public key cryptography. If a request comes in and it's signed by someone we trust, we'll take it, right? We know who you are, or we don't care who you are. Like, we should be able to field queries and transactions that are one-offs, where the database doesn't know at all. So you should be able to delegate authority. And has anybody here heard of verifiable credentials? Okay, you guys don't count. They're my coworkers. It's just a standard for a shape of JSON, again, JSON-LD, because it's all just data, for passing around signatures as data. And so if somebody we trust signs a credential and says, yeah, you can query this stuff, well, we're like, all right. As long as you're authorized to do that. So we do make sure that people aren't just running away with data. We've got a data representation of security policies. And then for validation, we use the shape constraint language, Shackle. It's got a bunch of different constraints. It's a very expressive data DSL for specifying validation rules. But like, the whole database is designed a la carte. Like, if you want to sort of make data sharing cheap, do this stuff, please. But, you know, not all shipping happens in containers. Sometimes you're just carrying a box of cookies to your neighbor, or maybe you're trying to ship an orca to SeaWorld. Who knows? You're not putting that in a container. Or maybe you've got to get an envelope to somebody in Japan in 13 hours, as fast as you can. So you give it to somebody and they hop on a plane. So this isn't going to cover every use case, but just like containers didn't take over everything in order to provide value, they took over enough that it made a huge difference. So, ideally, now data sharing isn't so darn expensive. And you don't have to jump straight in. I like to compare the experience of cheap data sharing with the process of sitting and doing REPL-driven development. I spent a little bit of time doing front-end work in TypeScript where I had to think really hard about, how to change the code and think about how it was going to work. And I went back to developing in Clojure, and I was sitting and contemplating a change that I wanted to do. And after 30 seconds, I was like, wait, what am I thinking about this for? Let's just see what happens, right? I can play with my program while it's running. Same way, we can play with data. And there's so much that we can unlock. When data is cheap, federated queries are when you just join databases. You can't do that with a relational database. The schemas are different. So somebody has to sit down and figure out, Postgres has the foreign data tables, right? How many people have set up a foreign data table in Postgres? Yeah. It's awesome that you can, but it's a project, right? So what if it wasn't a project? What if it was just an extra clause in your query, and then bam, you've got the data right there. You don't need a budget. You just need to know, what's the name of the database, right? Bam. It's right there. And vocabulary mapping. So you say I've done this, and I've joined 2 databases, or 8 databases, because you can do that. Well, now I've got this semantic problem. I've got an employee ID, and you've got an account ID, and you've got an EID, whatever that is. Are these the same things? Well, all you have to do is, I talked about the web ontology language a while ago, OWL. OWL is for inferencing. And so you can add one fact that says, account ID is the same thing as customer no. And now every time you query for one, you get the results for everything. You didn't have to go update everything. You didn't have to go through an ETL pipeline. You didn't have to scrub and clean data. You just inferred the relationship. You just put it in the data right alongside everything else, and it just does the right thing. And you could go much further with inference. Say genealogies, right? Brother, sister, mother, father. These are all different predicates in our database. And I'm like, I don't want to have to do, every time I do a query, say, is brother of, or is sister of, or is parent of, or is child of. Because that's tedious. Well, more than just tedious, sometimes it's just too complex. But if I add a couple of facts that say, oh, hey, guess what? If you're a sister, then that's a sub-property of family. I add that one bit of data, and now I can write, just give me all the family members of this thing. And because Sparkle is this beautiful graph query language, we can handle recursive queries really well. It's very nice. Data viewers. You want to play with your data. We get to do this in Clojure. They're fantastic projects like Clerk or Portal or Rebel or Data Rabbit. Have you seen Data Rabbit? It's really cool. If you haven't, check it out. If you have to deal with data, like, we've got this rich ecosystem of tools in the Clojure world. And other people deserve that, you know? Like, just because they don't know how great Eden is, they should still have a chance to experience that. Because it's so much easier. It's just easier. We talk about simplicity a lot, but hopefully, eventually, when you compose simplicity, you get easy solutions to hard problems. That's the point, right? Rapid application development. I just want a form, right? Basic CRUD. Why do I have to spend all this time wiring up the validation, the authorization, all this work? Just declare what it is and bam, you're off to the races. Right now, most people, their relationship with data is, I am going to go to someone else, and they're going to hold on to my data, and they're going to use it to generate more data, and they may allow me to see some of that. But the purpose of letting me see that isn't for my benefit per se. It's so that they can sell it to other people, they can market to me. And this paradigm kind of stinks. When the data can defend itself, why not flip the paradigm? Instead of bringing the data to the application, bring the application to the data. You give me your algorithm and I'll run it over here and I'll generate the data and maybe I'll share it with you, you know? That's a better way, at least for me as a user. I like that. And if joining data from many sources is cheap, we don't need big data. You can have small data all over the place and just join it ad hoc when you need it. That's better. They say data is a liability. When you got big data, people try to get at it. Small data, is it worth it? Who knows? And when you can share data freely, cheaply, you start to get a new class of problem. You start to say, where did this data come from? Who created this data? Do I trust that source? So in Fluree, we sign our transactions and link them so that one, you can tell that nobody's tampered with the chain of data, and two, so you can tell where it came from. You can query the provenance of the data because we store it as triples in the database, right alongside the user-submitted data. And I jumped ahead to federated computation. That's what I'm talking about, bringing the app to the data instead of the data to the app. And this has been a wild ride making this for Fluree. We're currently in a pre-alpha state for our JSON-LD support. Like, we've got a database that works and people use it to solve real problems. We're currently working on incorporating JSON-LD into the very guts of it because we looked at this problem of sharing the data and we realized that we want to be able to do it really well. And so it's important to get the primitives right. Like, every time you see an application server, a different one, done a different way, that's like, we don't build those servers just as ends in themselves. The purpose is for something else. It's to enable data to work. But the fact that we have to do it again each time is because we lack the critical, like, base data infrastructure to make it cheap and easy. And so we've got strong opinions about that, and we want it to be cheap and easy because it should be cheap and easy. Data is becoming more important all the time. I want to say something about AI, but I've only been paying attention for 2 months, and like, they're doing stuff with data. If we can't also do things with data, wow, who knows? So, like I said we're pre-alpha. We're barely pre-alpha. Like, we're going to have a release in like the next week or so. So please come check us out. These are some links. Our website, our docs, you can find that there. This is our repo. Check it out. Clojure, it's written in Clojure. It's actually written in CLJC. It's embeddable. You can embed it into your Clojure programs. You can embed it in any JVM language. You can put it in the browser. It runs on Node. Clojure has been amazing for this. It gave us so much leverage. And I also want to put a shout out for Clojure Camp. Daniel Higginbotham helped me a lot in putting this talk together. He gave a lot of really useful feedback. And so did my colleagues at Fluree. But Daniel's actually got a booth in the back for Clojure Camp for bringing people into Clojure, which I think is a really great idea. So I just want to give a shout out. Stop by the booth. Say, yes, I will help people learn. Because it's friendly and fun that way. Here's a bibliography. If you want to learn more about containers, this book, The Box, is worth reading. It'll really suck you in. And how are we doing on time? What? We're out of time. Okay. Thank you very much.